Alright guys, so this video is going to focus on how do we expand logarithmic equations. So there are three important rules that you need to be aware of whether you're expanding logs or you're condensing logs. So there's the product rule for logs, the quotient rule for logs, and the power rule for logs. So the product rule for logs essentially says that if you are multiplying two terms together, so like example A, we have log base b of x squared times y. If there is a multiplication, the way that you expand that is that you separate the logs using an addition. Okay. The quotient rule for logs says that if you have a division in your expression, like we do for example b, c, and d, we have x squared times y divided by z to the 8th. We have this x divided by z, and then we have this whole numerator here divided by the z to the 6th. So when you have a division, that pertains to the quotient rule. And the quotient rule says to take that division and you're going to expand it out, separating the logs using a subtraction symbol. The last one is the power rule. So the power rule says if you have a power, like we have x squared, z to the 8th, even a square root is considered a power, because remember, a square root is the same thing as raising something to the 1/2 power. So the way that the power rule works is if you have an exponent, you expand that by taking that exponent and it becomes the coefficient of the log, so it goes in the front. So those are the three main important rules as it pertains to expanding and condensing logs. Let's go ahead and work through these four examples, and let's see how that goes. So example A, we have log base b of x squared times y. So there's two rules that we're going to be using for this one here. Those two rules pertain to, well, I have a multiplication here, so the multiplication refers to the product rule. And then I have an exponent here. So the exponent goes to the x, not to the y. So remember that an exponent correlates to being shifted down to the coefficient. So this is how this is going to work. Because I have two different terms, I have an x and I have a y. When we're expanding, we're taking this log and almost think about like distributing the log to everything inside the parentheses. I have an x and I have a y. So I'm going to distribute the log by doing this. Log base b of x, and then I have it times y. But remember, using the product rule, a times correlates to a plus. So then I'm just going to distribute again. Log base b now of the y. So I'm taking this x and this y and I'm separating them. I'm expanding them using an addition symbol, because remember, multiplication is addition, division is subtraction, power is a coefficient. So that takes care of the multiplication here. The only other thing left to take care of is the power. So that was an x raised to the second power, so I'm taking a look at the log over here that pertains to x. Instead of the exponent going on the x, it's now going to become the coefficient and go to the front. Otherwise, that is the solution for this. Distribute the log, essentially. Again, the multiplication turns into addition, and the exponent just goes down in front. So let's see if we can then move on to example B and work that. So if I look at example B, I have log base b, I have x squared times y divided by z to the 8th. So I have three different letters: log of the x, log of the y, log of the z. So I am going to split this up three different ways. Okay, I'm going to distribute that log. Alright, so I'm going to start with the numerator. So we have log base b of the x, and then we're multiplying that to the y. So remember, multiplication is an addition, and then I have log base b of the y. The x, remember, has a power of a 2, so remember that then goes in front as a coefficient. The only other thing I have is I'm now dividing by z to the 8th, so I'm now distributing that log to the z, but because it's a division, remember that is the quotient rule, which tells you to subtract. So I'm going to subtract this log base b of z, since it's a division. Division is subtraction, multiplication is addition here. That z was being raised to the 8th power, so that means that that 8 now becomes a coefficient. So just double checking everything. I have log of x, the 2 goes in front. We're multiplying, so that's a plus of the log of y. There's no exponent of y, so that one's fine. We're then dividing, so that's a subtraction of the z, and then this 8 goes in front. So everything looks good there. Example C. So before I convert example C, before I expand it, I'm going to rewrite example C. Remember that a square root is the same thing as raising it to the 1/2 power. So this is really log base b of x divided by z to the 1/2 is what that is really saying. And this helps me here because I see I'm going to distribute the log to the x and to the z, but both of them are being raised to that 1/2 power. So that means we have to use the power rule for both of them. So, okay, so I'm going to distribute the log. So I have log base b of x. It's being divided by the z, so that's the subtraction of log base b of z. Both of them are being raised to the 1/2 power, so both of them have to have a coefficient of a 1/2 because that power goes to both of them. Okay? Otherwise, that's that one. Example D. So I have log base b of an x, a square root of x, so remember that's the same thing as x to the 1/2. I have log base b of the y to the 9th, log base b of the z to the 6th. So 1, 2, 3 factors here. That means I'm going to have 3 logs that they're going to separate into. Starting with log base b of the x that we have there. Remember that x, that square root, is really saying a 1/2 power. So we can bring that down to the front as a coefficient. That's being multiplied times the y. So remember, multiplication is a plus. So plus log base b of the y. That y is being raised to the 9th power, so I want that 9 here in the coefficient in front. And this is now being divided, so that's a subtraction of log base b of the z. And that's being raised to the 6th power, so we need to make sure that we bring down that 6 as the coefficient there to wrap up that problem. Otherwise, that is how you expand logs using the product, quotient, and power rules. That's it for this video.